Hi everyone. So, do you all remember the idea of call stack? So, if you'd have learned recursion, you might have seen a term called as call stack. What exactly is a call stack? It is a simple thing. It's a simple stack of function calls that are waiting on each other. For example, let's say main is our first function, then this main will be pushed inside a call stack. The moment it makes a call to func1, func1 will also be pushed in the same call stack. The moment this makes call to func2, func2 will also be pushed in the same call stack. Now, when func2 returns something, func2 will be popped, and whatever it returns, that will fall on func1. Func1 will catch it. Why? Because they are part of the same call stack. Now, why does it happen that whenever a function returns a value or returns an exception, then that lands on the calling function? It happens because they are part of the same call stack. If they are not, this behavior cannot be expected. Okay, now this brings us to a very important question. The question is that whenever we create a thread and start it, then is that also a part of our current call stack? The answer is no. Why? Because call stack is something which is specific to thread. What I mean by that is that if there are 10 different threads that are currently running, they will have their own call stacks. Call stack is private to a thread. They are not shared. So that's an important point to be kept in mind. So the moment you create a new thread and launch it, then do not assume the functions triggered by that thread to remain in the current call stack of your main thread. They will be having their own separate call stack. It's an important concept to know. Now, because of this concept, there are certain repercussions. What I basically mean by that is, I have seen people writing concurrent programs and expecting them to behave in a certain way. And at times, it doesn't behave that way. Why? Because people lack the understanding of some fundamental concepts. So I'll show you something like that. But for now, if you take a look at this particular piece of code, what do you think will happen if I run it? So I can see that func1, when it is called, it calls func2, and func2 returns 0, which is caught here. And the moment x is 0, it throws an exception, which again will be caught here. And because of that, this statement should ideally be printed. Now I have run my program, and let's see what actually happens. So we can see that is what exactly has happened. Okay, so far so good. Now guys, having understood this thing, let's think of a concern, let's think of a question. Let's say if I created a new thread and I launched that new thread from my current thread, which is my main thread, for example. Now, whatever value that thread returns, will I ever be able to catch it? The answer is no. Why? Because that thread will have its own call stack. So if it returns a value, I'll never be able to catch that. Similarly, if it returns an exception, I'll never be able to catch that. So let me give you a simple example. So what I have done is I have created a random runnable, and this runnable contains a run method which throws this runtime exception. Okay, now I am going to go back to this place and I am going to simply create a new thread. So this is my thread T, and this thread T will be composed of my runnable, which I just showed to you. Okay, and you have seen that its run method will simply throw a runtime exception. Now the moment I do t.start, I know for sure that there is an exception which is going to be thrown from here. Now at times people feel that because an exception is going to be thrown from here, it must be caught here, but it will never be caught. Why? Because when you do t.start, then this run method which is invoked as a consequence of that is not a part of the same call stack. So whatever it returns or whatever it throws will never be caught over here. This is an important point to be kept in mind. You know, that is probably the reason because of which the people who designed thread class or people who designed runnable interface, they wrote methods that did not return anything. Run method does not return anything. Similarly, if you look at the t.start, this start method is also void. It does not return you anything. Okay, cool. You can even test this out. So in order to test it out, I just have to run this program, and I can see that this caught message has not been printed. It has not been printed. Yeah, there is an exception that I can see over here. That exception is because there was an exception that got thrown here. So it has been printed over here. So what really happened was that the thread T that I created, it threw this exception, and that exception has been printed over here, but there was no one to catch that exception and do something on top of it. Okay. Similarly, if let's say I had created a thread with an intention to let it perform some computation and return me a result, then I cannot get hold of that result directly from that thread. I can't expect it to return it to me the way functions return. So, in such scenarios, whenever people have to write concurrent program where they want to launch multiple threads and they want those threads to return some values, what do? What can be the solution in such a scenario? Can you just pause the video and think about it? A simple solution could be, in the last lecture, we discussed that threads can share some variables. So let's say I launched a thread T, which performs some computation and generates a result. Then what I can do is that I can let that thread assign the value of that result to some global variable, which is accessible to my program. And once that thread terminates, then I can fetch the value of that global variable. So when you deal with concurrent programs, these kind of orientations you have to keep. You can't have the orientation of a simple sequential program. Otherwise, what you might expect could very well be different from what you actually get. So it's an important point. Threads have their own call stack, and threads cannot return something, or they cannot return a value, or they cannot return an exception. You can't catch hold of them basically. You have to resort to some other activity, maybe using some global variable for that purpose.